Okay, so for today we are going to solve differentiation for parametric equation by using chain rule actually. So if we have y in terms of t and x in terms of t, but we want to find dy dx, so we need to use parametric equation. So dy over dx is equals to dy over dt times dt over dx. Okay, but we have x in terms of t, so that's why it becomes dy over dt divided by dx over dt. Divided by dx over dt. Okay, so this one we change to this one. So that's how the formula is this one. So if we have y in terms of t and x in terms of t, and we want to find dy dx, so the formula for dy dx is equals to dy over dt divided by dx over dt. So we need to find what is dy over dt and dx over dt. So what is dy over dt here? So I have to solve this one. So we need to use product rule, okay? So for dy over dt, u is equals to t squared, v is equals to sine 2t. So u prime must be equals to 2t, v prime must be equals to 2 cos 2t. So dy over dt is equals to 2t squared cos 2t plus 2t sine 2t. Okay, and then your dx over dt is straightforward, so you get 6t power 2. So now we just substitute in the formula, so you will get dy over dt, so you just substitute the value here or the function that you got, 2t sine 2t divided by 6t squared. So if you can simplify, just simplify it, okay? So here you can simplify 2t, right? So 2t will remain outside, so you have t cos 2t plus sine 2t divided by 2t times 3t. So cancel this, so the final answer will be dy over dx is equals to t cos 2t plus sine 2t over 3t. That's it. So that is how you solve for dy over dx for parametric equation. Okay. Next, let us try to do these 3 examples. Okay, the first one, find dy dx. Okay, when t equals 0. So now it's given t equals to 0. So we need to substitute the value of t after we get the dy dx. So again, to obtain dy dx will be dy over dt divided by dx over dt. That's it. So here, find dy over dt first. So you will get 3 t squared minus 3 power 2 times 2t, and if you want to simplify it, you will get 6t t squared minus 3. and dx over dt would be negative 6 exponent negative 2t. So your dy over dx, we use this formula, so you will get 6t t squared minus 3 divided by negative 6 exponent negative 2t. Okay, now we can cancel 6. So the answer, the final answer would be negative t. Okay, we can expand it, t power 3 minus 3t over exponent negative 2t. So this is your dy dx, the final answer that we want. Okay, that's it. Very simple. We just substitute in the formula. So how about p? Okay. So the dy dt will be 2 sine t cos t. Dy over dx will be 12t power 3 plus 1. So your dy dx is just dy dt over dx dt. So 2 sine t cos t divided by 3 squared plus 1. That's it. You can just stop there. Okay. How about c? Will be dy over dt. Okay. Differentiate y respect to t, so you will get 2t minus 2. Dx over dt will be 1 over t. So next, dy over dx, use this formula again. So 2t minus 2 divided by 1 over t. So it's actually t 2t minus 2. You can just stop there, or you can write again. It is 2t squared minus 2t. So this is the final answer. Okay, so that's it for parametric equation, differentiation of parametric equation. Very simple. Next. So now implicit differentiation. So before we learn how to differentiate implicit differentiation, you need to understand or know what does it mean by implicit function. So you can see here, this equation defines an implicit relation between variable x and y. Meanings, you cannot explicitly write y equals to a function of x. Okay, you cannot separate y and x. It's hard to separate. So this is called implicit. For example, like this, you will get y squared equals to 25 minus x squared, and then you need to perform the square root, so you don't want the square root. And this one also, xy here, you cannot separate. So when we cannot put an equation fxy equals to 0 in the form of y equals fx, use implicit differentiation. So we need to apply implicit differentiation whenever we cannot separate them. So differentiate both sides of the equation with respect to x, treating y as the differentiable function of x. So we differentiate respect to x. So collect terms dy dx on one side of the equation. Solve for dy dx. So let's take a look at this. So now we want to perform the differentiation implicitly, not explicitly what we have done before. So now to do this is we differentiate respect to x. So here will be 2x. Okay, and then y squared will be 2y. But we need to put dy dx. Okay, multiply by dy dx. So every time you differentiate function y, you must multiply by dy dx equals to 0. So now we will write in terms of dy dx. So we move negative 2x to the left. So dy dx will just equals to negative 2x over 2y. So we can cancel the 2. So your dy dx will just be negative x over y. So that's it. So the key for implicit differentiation is the dy dx. So every time you differentiate y, you must multiply by dy dx. Okay, no need for x, only for y only. Okay, so let's take a look at the next example. Okay, for A right here. So 2y, remember, multiply by dy dx. Okay, every time you differentiate y plus, so x times y here, you need to perform product rule because these are two different variables. So it will be u equals to x, ini product rule, y equals to v equals to y. So u prime equals to 1, v prime equals to 1. So 1 dy dx. Okay, because every time you differentiate y, you need to put dy dx. So now your differentiation will be equals to x dy dx plus y. So we put it here, x dy dx plus y equals to 0. So now we need to collect the dy dx. So first we move the y here to the right. Okay, y here to the right. So it will be 2y dy dx plus x dy dx is equals to negative y. And then we factor out dy dx. You'll get 2y plus x equals to negative y. So we move 2y plus x to the right. Get negative y, divide by 2y plus x. So this is the answer for your dy dx. Okay, so the key is you need to multiply by dy dx every time you differentiate y. So for B, so this one, x squared, y squared, negative 25, there's no product rule involved. So just straightforward, 2x plus 2y dy over dx. Differentiate 25 is 0. 0 is 0. So now will be 2y dy over dx is equals to negative 2x. We move to the right, and then we left only with dy dx will be negative 2x over 2y. We cancel the 2, so dy dx is equals to negative x over y. Okay, that's it. For C, okay, so you need to use product rule for this one, but we have done it here, so I just take the value. So x power 3 differentiate, we'll get 3x squared plus 3y squared. Don't forget dy dx minus 9. Okay, we differentiate xy just now, so just take the value here. Okay, I'll take the value here. X dy over dx plus y equals to 0. So you simplify it first. 3x squared plus 3y squared dy over dx. I will expand first. 9x dy over dx minus 9y equals to 0. So we move the term with no dy dx to the right first. So 3y squared dy over dx minus 9x dy over dx is equals to negative 3x squared plus 9y. Okay, this one and this one. and then we will factorize the dy dx. 3y squared minus 9x is equals to negative 3x squared plus 9y, and then we move the term other than dy dx, so it will be negative. Okay, so the dy dx will be negative 3x squared plus 9y divided by 3y squared minus 9x. Okay, you can simplify and you can also stop here. Okay, that's it. Okay, thank you very much. This is the video is on the parametric equation, differentiation, and also the implicit differentiation.